Hello everyone. In this video we're going to be integrating a somewhat rational function in two different ways. We have 3 times e to the power x plus 5 divided by 2 times e to the power x plus 7. And let's go ahead and see how we can integrate this in two different ways. Let's start with the first method. So I'm going to write our expression. Obviously, for these kinds of things, the first thing you should look at is the numerator, the derivative of the denominator, in which case you will get an easy ln, right? But that's not the case here. So let's go ahead and do this. We can go ahead and split up the numerator, 3e to the x divided by the denominator. So in other words, we can kind of split it into two fractions, whose sum gives us the original. Okay? Now, why are we doing it? Because we can kind of get to the ln phase here. So if you look at this carefully, for example, if I call this u by using a u sub, if u is equal to 2 times e to the x plus 7, then du, which is going to contain the derivative, right? The derivative of 2e to the x plus 7 is 2e to the x, and then I have to add the dx, right? Well, we didn't exactly get what we have, but we're pretty close because we need 3e to the x, we have 2e to the x, so that can be adjusted, right? Very easy by a change of coefficients. What about the other one? Okay, that's an interesting one. This one doesn't have the derivative in the numerator, so we kind of have to treat it differently. And the way we do that is basically by multiplying the top and the bottom by the reciprocal of e to the x, which is e to the power negative x. And let me show you how that works. So, okay, so for the first part, we have 3e to the x divided by 2e to the x plus 7 dx. And then for the second part, we have 5 over 2e to the x plus 7 dx. But I'm going to go ahead and multiply this by e to the negative x and e to the negative x. And of course, do not forget the dx. Okay? Now, here we call this u, and u equals 2e to the x plus 7. We've done that before, but anyways, we can do it again. du equals 2e to the x dx. Now, we do have 3e to the x, so we can basically multiply both sides by 1/2. So ex dx would be half of du, and then 3e to the x dx would be 3/2 of du. Okay, so this is what we get from the first one, and 3/2 you can kind of pull out du divided by u. And as you know, this is the ln absolute value of u, plus c, but we're not going to use it since we're going to add it at the end. Okay, that's the first part. So we're kind of, and of course, back substitute. What's u? U is 2e to the x plus 7, 2e to the x plus 7. By the way, this is not this cannot be negative or even 0. So this is a positive quantity, which means you don't need the absolute value anymore. 2e to the x plus 7. Okay? Don't forget the 3/2. So that's part of our solution. And now we're going to go ahead and do this here. For this one, we can actually, well, first of all, we have to distribute. Let's do the distribution. This is going to be 2. When you multiply these, it's going to give you 1 because it's e to the power 0. And this will be e to the power negative x dx. Now, we kind of use the u sub again, but forget about the previous u. This is a new u, okay? That's a u. Now, u is equal to 2 plus 7e to the negative x. And du would be, okay, if you differentiate this, you're going to get negative 7e to the negative x dx because of the chain rule. The derivative of negative x will bring an extra negative 1, okay? Do we have that in the denominator? I mean, in the numerator? Nope, we have 5. So let's go ahead and multiply by negative 1/7 first to get that. And then multiply by 5, or you can just totally plot 5. It's totally up to you. E to the 5e to the x, 5e to the negative x dx is going to be negative 5 over 7 du. Okay? Then our integral is going to turn into negative 5 over 7. We'll pull that out. Du divided by u again. So it's the same ln thing with a different coefficient, right? It's going to be ln absolute value of u, but again, u is non-negative, it's positive. We can write it without the absolute value. Okay, now let's go ahead and put these two together, and then we'll get the answer. Make sense? So 3e to the x plus 5 divided by 2e to the x plus 7 dx is going to equal, what was the first part? 3/2 ln 2e to the x plus 7 minus 5/7 ln 2 plus 7e to the negative x plus c at the end. Okay, takes up a lot of space, so maybe we can move this to the left a little bit. Oops, didn't work. Let's see. We're gonna go ahead and take this and move to the left a little bit so that we don't have to cram it into that corner, you know. I don't like when the plus sign and everything else mixes up. As you know, 2 plus 7e to the negative x plus c. Okay, awesome. So that's the first method, and basically just split it up and solve like that. The second method is slightly different, and actually it's really cool because I think it's very different. Okay, we're going to do something interesting here. So we're going to go ahead and take the numerator. We're going to split it up again, but in a much more meaningful way. Okay, so we're going to write this as a linear combination of 2e to the x plus 7, which is the denominator, and the derivative of the denominator, which is 2e to the x. And you'll see why in a little bit this works. So this is basically the derivative. That's why we wrote that, okay? Now, of course, we're going to find the a and b values, but this is easy polynomial-wise. You're going to distribute, set it equal to this, constant term equals to that. Let me just give you the values. Without further ado, a is 5/7 and b is 11/14. So what do you get from here? We basically get the split, 3e to the x plus 5 divided by 2e to the x plus 7 dx. Can be now split up, and of course, I'm going to take the 5/7 out. This is going to give me 2e to the x, I don't know why I keep saying x, that's in Turkish, x, 2e to the x plus 7 divided by itself, you know what that is, plus 11/14, 2e to the x divided by 2e to the x plus 7 dx. Okay, great. Now, here's the thing. When you look at this, this is 1, isn't it? Uh-oh, that's interesting, right? So what is the integral of 1? X, right? So this is going to give you 5/7x. What about this one? Well, if you call this u, it's going to be the du here. So directly you get that. That's why we were looking for the derivative. So it's just going to be the ln of the denominator, which is this one, right? Now, here's a $1 million question for you. Of course, there's a constant at the end too. Why is this different from the other one? That's basically for you to find out. The answer isn't that hard, but I want you to think about it because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe. Take care. Don't forget to check out SyberMath and aplusbi, which is about complex numbers. And bye-bye.